Hello, welcome to Ella's Academy. This is Mathematics SS2 third term. Mathematics is a very simple subject. Mathematics is a subject all students need to succeed. As a matter of fact, mathematics and English, these two subjects are the basis of everything students want to learn in school. You need knowledge of mathematics, you also need knowledge of English. Though research show that more than 70–80% of students in school hate mathematics due to the fact that the kind of teacher, the methods which those teachers are using for them is not it's not acceptable. Please, I congratulate you. You are here in Ella's Academy. We are going to reveal everything to you about mathematics. Now, this is SS2 third term. We want to look into trigonometry ratio, which is revision. After trigonometry ratio, we are going to circle theorem. So, follow us and see what we are going to give you. Now, circle trigonometry ratio. If you look at the board, what we have here is right angle triangle. We have what? Right angle triangle is what we have here. Look at the board. We have right angle triangle. Now, we want to state the ratios. Now, using this right angle triangle, we have angle theta here. We use C to be our angle theta. Then opposite C, we have small letter c. So between angle 90 and theta, we have small letter b. That is our BC, which is small letter a. Our AC is b. So this place is called hypotenuse. Hypotenuse. So why this is called opposite? Why this one is called what? Adjacent. So any side facing this angle here, any side facing angle theta is opposite. So any side facing angle 90 degree is our hypotenuse. Between angle 90 and theta is our adjacent. So now let us state our three ratios. Now what we are going to use by applying what we call SOHCAHTOA. By applying what? SOHCAHTOA. So means sin theta. Sin theta equals to this 0 means opposite over hypotenuse. What's our opposite here? C. Our hypotenuse is what? B. So now let's look at CAH means cos theta equals to adjacent. This A means adjacent. Adjacent over hypotenuse. So what's our adjacent? Our adjacent is A. Hypotenuse is what? B. And the third one is TOA. Our TOA means tan theta equals to opposite over adjacent. Our opposite here is C, then our adjacent is A. Our adjacent is A. So that is the three trigonometry ratio that we have. Now, each of this one, they have what we call reciprocal. They have what? Reciprocal. Now let's look into their reciprocal. Reciprocal means 1 all over. 1 all over. So from here now, for sin theta, 1 over sin theta. So what is our sin theta? Our sin theta is C over B. That is 1 over C over B, which is the same thing as B over C. Which is the same thing as what? B over C. So let me just do the proof for you, then I will clean the board. 1 divided by what? C over B. Then from here, your 1 this division to multiplication, your numerator will go up, and your numerator will go down, then the denominator will go up. Your denominator is b, numerator is c, that means b over c. So 1 times b over c will give us b over c. So now let's look at the third one, the second one. I mean 1 over cos theta is the same. What's our 1 over, what's our cos theta? Our cos theta is a over b, which is the same thing as b over a. Okay, let's look at 1 over tan theta. 1 over tan theta. So 1 over tan theta is the same thing as 1 over c over b, which is b over c. Now, if you look at this ratio, if you look at this ratio, this reciprocal of these ratios, so what we get, the first one, which is 1 over sin theta, is cosecant. Is what? Cosecant. That is cosec. Is what? Cosec. This one is called what? Cosec. The first one is what? Cosec. Cosec. That's our cosec. The opposite of sin theta is cosec, which is cosecant. The opposite of sin theta is cosecant. Now, the opposite of cos theta is sec. Is what? Sec. Is sec. The opposite of cos theta is sec, that is secant. The opposite of cos theta is secant, which is sec. While the opposite of tan theta is cotangent. The opposite of tan theta is cotangent. Is what? Cotangent. That is cot. Is what? Cotangent. Cot. Cotangent. That is cot. So that's about the three trigonometry ratio and their reciprocal. So let's look at something. Let's look at sin theta divided by cos theta. What will it give us? Sin theta divided by cos theta. So let's see. Sin theta divided by cos theta. So what's our tan sin theta? Our sin theta is c over b divided by, this is divided, cos theta. Our cos theta is a over b. So it, which is from here I can say c over b times, then this b will go up, b over a. So that by b we cancel b, we have 1 c times 1 c, then 1 times a. So now if you look at the sin theta divided by cos theta, is the same thing with tan theta. It's the same thing with what? Look at tan theta here. Our tan theta is c over a, while our sin theta divided by cos theta is c over a. So that means even though it no use the ratio of 12 to get your tan theta, you can also use sin theta divided by cos theta to get your tan theta. To get your what? Tan theta. So let us solve one example on this. So let us solve example on this trigonometry ratio. So we have a question here. Given that sin theta equals to 8 over 17, calculate the values of cos theta, tan theta, cos theta plus sin theta all over cos theta minus sin theta. So from here we have sin theta b. So we need to draw our trigonometry ratio and our right angle triangle to divide this. So now let me call this theta. So by saying that our opposite, we have sin theta. Our sin theta equals to 8 over 17. And you know that sin theta is opposite over what? Over hypotenuse. So our opposite is 8. Then our hypotenuse is what? 17. Let me name it A, B, C. So now before we can solve anything, we need to get the third side, which is our BC. Our BC. So then to get our BC now, we are going to apply Pythagoras theorem. By Pythagoras. By Pythagoras. By Pythagoras. So we have BC squared. So So by Pythagoras theorem, our hypotenuse squared equals to opposite squared plus adjacent squared. Then our adjacent squared equals to hypotenuse squared minus opposite squared. Then our opposite squared equals to hypotenuse squared minus adjacent squared. So that is the formula for Pythagoras theorem. And what we are looking for now is our adjacent here. So which is our adjacent minus hypotenuse squared. So our hypotenuse is AC squared minus opposite AB squared. That means our BC squared equals to AC squared 17 squared minus AB squared, that is 8 squared. So from here our BC squared equals to, now if you look at the 17 squared, then your 17 squared will give you 289. Will give us what? 289 minus 8 squared. 8 squared will give us 64. So that means BC squared equals to, then when you subtract 289 minus 64, it give us 225. Then put square root to both sides. Find square root both sides. Square root both sides. So by square root both sides, and we have our BC equals to root 225. So our BC now, what is square root of 225? Square root of 225 will give us 15. 15. So here is what? 15. So now we want to solve. Let's solve for the first one, which is cos theta. Our cos theta equals to adjacent over hypotenuse. Adjacent over hypotenuse, that is A-ish. So our adjacent is 15, hypotenuse is 17. Then the other one is tan theta. Tan theta equals to 2 opposite over adjacent. So our opposite is 8, adjacent is 15. So the next thing we need to do now is to solve for this, the third one, cos theta plus sin theta divided by cos theta minus sin theta. So by so doing, what's our cos theta? Our cos theta here is 15 over 17 plus, what is our cos theta is 15 over 17 plus our sin theta. Our sin theta is 8 over 17 divided by this division, cos theta again, 15 over 17 minus 8 over 17. So from here you find the SM of this. SM of this is 17. 17 cancel 17, 15 plus 8 divided by here 17, 15 minus 8. So the next thing now is 15 plus 8 will give us 23. 23 over 17 divided by 7 over 17, which is equals to, now this one will now give us 23 over 17 times 17 over 7. This we cancel this, we have 23 over 7. So 23 over 7 is our final answer. Or now you ought to leave your answer like this, because your question was given to you in a fraction form. Although we can put it in a mixed fraction. 7 in 23 will give us 3. 2 over 7. So whichever way. So that is about the ratio of trigonometry. So let me just give you one question. You try it under this. I will give you one question so that you will try it under this SOHCAHTOA. So see the question I'm giving you. Just try this. Given that sin theta equals to 8 over 17, 0 less than or equal to theta, theta less than or equal to 19. Find the value of cos theta. b cos theta minus sin theta over sin theta squared. Don't be confused with this 0 less than 90, less than theta, or theta less than 90. So you are going to use the same method to solve for this. So we are moving to next class, and the next thing we want to do here is let's try. Let me check your scheme of work. Relationship between the ratios. So we want to check the relationship between the ratios. So the first one is sin theta divided by cos theta, which we demonstrated before. But let's do it again. So what's our sin theta? From the previous video, our sin theta is it not c over b? If you check your note very well. So I think our sin theta is c over b. Our sin theta is what? C over b. Sin theta is c over b divided by, let me just go through the point, c over b divided by cos theta. So our cos theta now, that is 12, and adjacent of hypotenuse a over b, which is the same thing as c over b times b over a. This will cancel this, which gives us c over a. That is our tan. That is tan theta. So, and the other one, let's check the other one. And the other one is cos theta over sin theta. Let's see. Cos theta over sin theta. So we want to look at the other way of it. Sin theta over cos theta. Cos theta over sin theta. Then our cos theta. What's our cos theta? Our cos theta is a over b divided by sin theta, c over b. That means a over b times b over c. This will cancel this. We have a over c. Then our a over c. What is our a over c? Our a over c is cot. Cot theta. Our a over c is cot theta, cotangent. Then the third one. So the third one is sin theta squared. Is what? Sin theta squared. Sin theta what? Sin theta squared. Now let's see the times theta squared plus cos theta squared. Plus cos theta squared. So now what is our sin theta? So our sin theta is c over b. Sin theta is c over b squared plus cos theta. Cos theta is a over b all squared. So from here it will now be equals to c squared over b squared plus a squared over b squared. Now I can find the LCM of this. The LCM of b squared is b squared. B squared can cancel b squared, we have c squared, plus d can cancel d, we have a squared. But if you go back to this, let's come back to our Pythagoras theorem. But by Pythagoras, b squared here, hypotenuse squared equals to c squared plus a squared. By Pythagoras, hypotenuse squared equals to c squared plus what? A squared. Therefore, from here, by Pythagoras, our b is equals b squared equals to c squared plus a squared. So therefore, anywhere we see c squared now, c squared plus b squared plus a squared, we put what? B squared over this b squared. Hello? Anywhere you see c squared plus a squared, it is the same as what? B squared. Because b squared is equal to what? This one. B squared is equal to this. Then we replace this by b squared. So b squared can cancel b squared. What we have is 1. Therefore sin theta squared plus cos theta squared plus cos theta squared equals to 1. Equals to what? 1. Now, if you need only sin theta squared only, sin theta squared is the same thing as 1 minus cos theta squared. So you bring this plus cos theta squared to the other side, it turns to minus cos theta squared. In the same way, our cos theta squared is the same thing as 1 minus sin theta squared. 1 minus sin theta squared. So, and this is the relationship that exists between both of them. So let's take example, or in the next video, because this one now is up roughly 21 minutes. So next video now, next chapter now, next part I will take examples on this.